Welcome back to Maths in an Empty Classroom with me, Mr. Southern. This is part 3 of the second lesson on compound angle identities, and in this video I'm just going to be taking you through a third example of using compound angle identities to solve an equation. So here we have solve for 0 to 360 degrees the equation 3 sine 2 theta plus 10 equals 5 cos 2 theta plus 40. So again, you have the skills to do this. Pause, try to work it out for yourself, think about what the key points are, and then play the video and see if what I say agrees with what you've written down. Be active, don't be passive. Okay, so here we have then 3 lots of sine 2 theta plus 10. So that is clearly the sine A plus B identity. So I would expand that out. Now crucially, because of this 3, I get 3 sine 2 theta cos 10 plus 3 cos 2 theta sine 10. Now, because it's 3 multiplied by sine of the bracket, when I expand the bracket to create the identity, I have 3 lots of each term in that expansion. And the same logic applies here for cos, so I would get 5 cos 2 theta cos 40 minus 5 sine 2 theta sine 40. Now again, you've got an equation that contains sine 2 thetas, and you've got also in there cos 2 thetas. So you'd be looking to use the identity sine over cos is tan. So what I want is the terms that have got sine 2 theta in them to be on the left hand side of my equation, and the terms with cos 2 theta in them to be on the right hand side of my equation, which is the next step I'm going to do now. So adding this term to both sides of my equation, I'm going to get 3 sine 2 theta cos 10 plus 5 sine 2 theta sine 40. And that is going to equal, if I subtract this term from both sides of my equation, that's going to equal 5 cos 2 theta cos 40 minus 3 cos 2 theta sine 10. Now I have sine 2 theta, I have cos 2 theta. I need to isolate those two functions. So on the left hand side I'm going to write sine 2 theta bracket 3 cos 10 plus 5 sine 40, and on the right hand side I'm going to write cos 2 theta and then bracket 5 cos 40 minus 3 sine 10. And just like the previous video, that's a number, that's a number. I want to create sine over cos, so I'm going to write sine 2 theta over cos 2 theta. That's dividing both sides of the equation by this cos 2 theta. And that's going to equal this number here, 5 cos 40 minus 3 sine 10, over this number here, 3 cos 10 plus 5 sine 40. Now crucially, because I've got sine 2 theta cos 2 theta, when I use my identity I get tan 2 theta, and I'm going to work out this number here specifically. So I've got 5 cos 40 minus 3 sine 10, and that's all over 3 cos 10 plus 5 sine 40, and that equals 0.53649. I'm going to be using that entire number in my subsequent solve. So I'm now at a point where again it's a relatively straightforward trig solve. I've got tan 2 theta equals 0.536. Just got to be aware of, at 2 theta, how many solutions am I expecting? Twice as many. So let's start off then. We'll do tan inverse of 0.53649 on the calculator. which comes out as 28.21. And I know that with tan it repeats every 180 degrees, so I can keep adding 180 degrees to these values. So I can say that 2 theta is 28.21, adding 180 is 208.21, adding another 180 is 388.21, and adding another 180 is 568.21. Now, because it's 2 theta, I'm going to need to divide each of these by 2, which is going to give me 14.1, 104.1, 194.1, and 284.1. And as you can see, each of those 4 values is in the acceptable range of 0 to 360, and I have 4 solutions, twice as many, because it's tan 2 theta. But key points to probably go back to is that at the very start here, when we expanded out sine of 2 theta plus 10, because of this 3, we had a 3 with each term of that expansion. And similarly here, because it was 5, we did the cos theta expansion, but each term was multiplied by 5 before we proceeded through the question. We noticed that we had a combination of sine 2 theta and cos 2 theta, which meant we could use the identity that sine 2 theta over cos 2 theta equals tan 2 theta. And there you are, that's job done. I'll see you in the next video.